Imagine peering across the unimaginable expanse of space, beyond billions of swirling stars, past clouds of cosmic dust, and gazing into a realm 8 billion light-years removed from our own. Now picture witnessing the birth of an entity so powerful, so mysterious, that it literally reshapes the fate of entire galaxies. This is not just a scene from a science fiction epic. It is the reality uncovered by a team of astronomers who, thanks to the most advanced telescopes ever built, may have observed the formation of a supermassive black hole, a cosmic event that could upend everything we thought we knew about the history of the universe. Why is this discovery sending shockwaves through the world of science? To answer that, let us rewind and lay the groundwork. Because the story of supermassive black holes is also the story of how our universe evolved from a swirling sea of hydrogen and helium into the intricate tapestry of galaxies, stars, and planets that we see today. For decades, astronomers have known that nearly every major galaxy, including our own Milky Way, hides a supermassive black hole at its center. These are not your ordinary black holes, which can form from the death of massive stars. Supermassive black holes are literal titans. Some weigh in at more than 1 billion times the mass of our Sun. To put that into perspective, imagine squeezing the mass of several billion suns into a region smaller than our solar system. The result is an object with gravity so intense that not even light can escape. As matter falls toward these gravitational monsters, it accelerates to near-light speeds, heating up and emitting vast amounts of energy. This energy can be so intense that the centers of some galaxies blaze with the light of 1 trillion suns, outshining the combined glow of all their stars. These are called active galactic nuclei, and they are among the brightest objects in the cosmos. But, more than just cosmic fireworks, supermassive black holes play a vital role in shaping the galaxies around them. They can trigger or stifle star formation, influence the distribution of gas, and even regulate the growth of their galactic hosts through powerful feedback processes. But a cosmic riddle has long haunted astronomers. According to what we used to believe, supermassive black holes form when smaller black holes, what scientists call light seeds, grow over billions of years, slowly gobbling up gas and merging with one another. This process is supposed to take eons. Yet, with the advent of powerful telescopes like the Hubble Space Telescope and, more recently, the James Webb Space Telescope, astronomers have been spotting gigantic black holes that already existed when the universe was just a few 100 million years old. That is a fraction of the universe's current age of nearly 14 billion years. How could these cosmic giants have grown so big, so fast? Enter the Infinity Galaxy, a system that could forever change our understanding of cosmic evolution. The Infinity Galaxy, so named because its 2 luminous rings resemble the sideways figure 8 symbol for infinity, lies roughly 8 billion light-years from Earth. That means we are seeing it as it existed when the universe was only about 2/3 of its current age. The Infinity Galaxy was first flagged by astronomers sifting through the vast digital archives of the James Webb Space Telescope. Its unusual shape, paired with its intense brightness at certain wavelengths, immediately stood out. But the real intrigue began when astronomers combined data from multiple observatories. Using the James Webb's infrared eye, they mapped the galaxy's structure, revealing 2 immense rings of stars and gas, likely the aftermath of a spectacular collision between 2 galaxies. Next, the Chandra X-ray Observatory added another layer, detecting high-energy X-rays indicative of matter being devoured by black holes. Finally, radio data from the Very Large Array provided further clues about what was happening at the galaxy's core. What they found was nothing short of extraordinary. Not only did the Infinity Galaxy appear to host the aftermath of a galactic collision, but the data pointed to the presence of not 1, not 2, but possibly 3 supermassive black holes. 2 were likely nestled within the original galactic nuclei, the dense central regions of the colliding galaxies. But the third, and most astonishing, was located between those 2 centers, embedded in a swirling cloud of gas. This was utterly unexpected. As Peter Van Dokkum, an astrophysicist from Yale University and lead author of the study, put it, "Everything is unusual about this galaxy. Not only does it look very strange, but it also has this supermassive black hole that's accreting a lot of material." The biggest surprise of all was that the black hole was not located inside either of the 2 nuclei of the merging galaxies, but in the middle. We asked ourselves, how can we make sense of this? To unravel this puzzle, the research team took a closer look at the velocities involved. If the black hole had migrated from elsewhere, perhaps ejected during a previous merger or lurking as the core of a faint third galaxy, it would likely be moving at a speed different from the surrounding gas. But using data from the James Webb Space Telescope, the team found that the velocities of the black hole and the gas cloud matched closely. This suggested that the black hole formed right there, within the cloud, and did so recently, perhaps within the last 50 million years. To put that in context, the Earth itself is about 4.5 billion years old. 50 million years is a blink in cosmic time. If confirmed, this would be the first direct evidence that supermassive black holes can form rapidly, not just in the early universe, but also as a direct result of galactic collisions, right in the middle of cosmic history. The implications are staggering. If supermassive black holes can form this way, it means the universe is far more dynamic and creative than previously imagined. Every major galaxy collision could become a crucible, forging new black holes not over billions, but over mere millions of years. This could explain why telescopes like James Webb have found so many enormous black holes in the young universe, far more than the old light seeds theory could account for. This brings us to a crucial turning point in astronomy. For years, the debate has raged between two competing theories: the light seeds model, where black holes start small and grow slowly, and the heavy seeds model, where massive black holes form rapidly from the direct collapse of enormous clouds of gas. Now, the Infinity Galaxy appears to provide real, tantalizing evidence for the heavy seeds scenario. Priyamvada Natarajan, a theoretical astrophysicist at Yale and co-author of the study, captures the excitement. What is exciting about the discovery of the Infinity Galaxy is that it hints that nature likely makes black holes via direct collapse throughout cosmic time. This means that the universe is equipped to create black holes not just in the distant past, but potentially at any era, whenever the right conditions arise. But what are those conditions? How does a galaxy collision turn into the birthplace of a supermassive black hole? According to Van Dockum, during the collision, the gas within these two galaxies shocks and compresses. This compression might just be enough to form a dense knot that then collapses into a black hole. In other words, when galaxies crash together, their gas clouds slam into each other at incredible speeds. This creates shock waves that compress the gas, possibly triggering it to collapse directly under its own gravity, skipping the slow star-by-star process. This process is not just a theoretical curiosity. It could have played a crucial role throughout the universe's history, especially in its early days, when galaxy mergers were much more common. In fact, recent observations have found examples of supermassive black holes feeding just 1.5 billion years after the Big Bang, and some of these black holes appear disproportionately large compared to the tiny galaxies that host them. This mismatch has puzzled astronomers for years, but if direct collapse is widespread, it could explain why so many galaxies, even small ones, harbor such massive black holes so early on. And this is not just about distant galaxies. There is growing evidence that our own Milky Way's central supermassive black hole, known as Sagittarius A, might itself be the product of a cosmic merger. Yihan Wang, a researcher at the Nevada Center for Astrophysics, points out, the misaligned high spin of Sagittarius A times indicates that it may have merged with another black hole. In other words, even the very heart of our galaxy may have been forged in the crucible of cosmic collisions. So what does all this mean for our understanding of the universe? For one, if direct collapse is a common mechanism, then the cosmic landscape is far more dynamic than we thought. Black holes may not be just relics of the ancient past, but active participants in the ongoing drama of galaxy evolution. Every major merger could trigger the birth of new black holes, shaping the structure and fate of galaxies for billions of years to come. This also forces astronomers to rethink the relationship between black holes and the galaxies that host them. Traditionally, it was believed that black holes grow in tandem with their galaxies, gradually influencing their environment through feedback processes, blasting out jets of energy that can either stimulate or suppress star formation. But if black holes can form suddenly, in the wake of violent collisions, then the timing and impact of their feedback could be far less predictable, with profound effects on how galaxies grow and evolve. For instance, a newly formed supermassive black hole can unleash torrents of high-energy radiation and powerful winds, blowing away gas that might otherwise have formed new stars. This could halt star formation in some regions, while triggering new waves of starbirth in others. Over cosmic time, these processes shape the diversity of galaxies we see today, from elegant spirals like our Milky Way to massive ellipticals and irregular dwarfs. The practical implications of this discovery ripple far beyond the realm of academic astronomy. The techniques used by these researchers, combining massive collaborative data archives and integrating information across different wavelengths and technologies, mirror the data-driven innovations revolutionizing industries here on Earth. Whether you are analyzing global financial markets, building artificial intelligence systems, or managing complex logistics networks, the ability to synthesize diverse data sources, adapt to new insights, and collaborate across disciplines is becoming the hallmark of successful organizations. The Infinity Galaxies discovery also underscores the power of open-mindedness and adaptability in science, as in business and technology. Ideas that once seemed unshakable can be overturned overnight by a single, spectacular set of observations. The willingness to challenge old models, embrace new evidence, and rethink assumptions is what drives progress. Whether you are exploring the deepest mysteries of the cosmos or navigating the shifting tides of the global economy. Moreover, this story is a testament to the role of technology in expanding the boundaries of human knowledge. The James Webb Space Telescope is a marvel of 21st-century engineering, combining the efforts of thousands of scientists and engineers from across the globe. Its ability to peer through clouds of dust, detect faint infrared signals from the earliest galaxies, and work in concert with other observatories like Chandra and the Very Large Array, is revolutionizing our view of the universe. In the coming years, even more powerful instruments, like the extremely large telescope in Chile, with its mirror spanning nearly 40 meters, will join the quest to unravel the secrets of black hole formation. But with every answer come new questions. If direct collapse is common, why do some galaxies, especially in the early universe, seem to lack supermassive black holes altogether? What determines whether a galaxy merger will spark a new black hole, or leave behind a more mundane aftermath? How do these newborn giants interact with their environments? Do they always stifle star formation, or can they sometimes ignite it? And what does all this mean for the possibility of life elsewhere in the cosmos? Consider, for example, that the energetic outbursts from an active supermassive black hole can sterilize vast regions of a galaxy, making them inhospitable to life as we know it. Yet at the same time, these outbursts can trigger shock waves that compress gas clouds and spark new generations of stars and planets. It is a cosmic dance of destruction and creation, played out on scales that dwarf our everyday experience. Astronomers are now racing to find more examples like the Infinity Galaxy. With the James Webb Space Telescope's unprecedented sensitivity, researchers are combing through thousands of distant galaxies, searching for the telltale signs of direct collapse black holes. Early results suggest that the Infinity Galaxy may be just the tip of the iceberg. Deep surveys have already uncovered a surprising abundance of supermassive black holes in the early universe, some existing less than 1 billion years after the Big Bang. These discoveries are challenging the very foundations of astrophysics. To determine whether the Infinity Galaxy's black hole is truly a newborn, astronomers will need more data. Detailed mapping of the gas dynamics, star formation rates, and chemical composition within the galaxy will help confirm whether the conditions for direct collapse are truly present. Future observations with the extremely large telescope and the next generation of space observatories will allow scientists to study a larger sample of galaxies, building a statistical picture of how and how often supermassive black holes are born. This research is not just academic curiosity. The story of black holes is the story of cosmic evolution itself. By understanding how these giants form and grow, we gain insight into the processes that shaped our own galaxy, our sun, and ultimately, the conditions for life on Earth. The same physics that governs the birth of black holes also drives the formation of stars, planets, and the elements necessary for biology. In a very real sense, we are all connected to these cosmic events. So what can you take away from this awe-inspiring discovery, sitting here on our pale blue dot? First, never underestimate the power of the unknown. The universe is full of surprises, and every time we push the boundaries of our technology and our imagination, we find new wonders waiting to be revealed. Second, the methods and mindset that fuel breakthroughs in astronomy, collaboration, adaptability, and the relentless pursuit of evidence, are the same principles that drive innovation and progress in every field. Whether you are a scientist, an entrepreneur, or simply a curious mind, the willingness to question, to adapt, and to embrace new perspectives will always be your greatest asset. And finally, discoveries like the birth of a supermassive black hole in the Infinity Galaxy rekindle our sense of cosmic wonder. They remind us that, for all our progress, the universe is still vastly mysterious, still teeming with secrets waiting to be uncovered. Each new revelation is an invitation to keep exploring, keep questioning, and keep reaching for deeper understanding. So as we stand on the cusp of a new era in astrophysics, let us marvel at what we have learned and dream about what we have yet to discover. Is the infinity galaxy a rare cosmic accident, or a glimpse into the universe's true creative power? Are there even more astonishing phenomena awaiting the next generation of telescopes and explorers? Only time and our own curiosity will tell. If this story has expanded your mind as much as it has ours, be sure to like this video and subscribe for more journeys into the frontiers of science and technology. We want to hear from you. Do you think the infinity galaxy is just the beginning of a new chapter in cosmic history? Or are even greater surprises still lurking in the depths of space? Share your thoughts in the comments below.